I've got a lot of demos to cram in. It's usually a 1-hour session. I'm going to try and fit it into 50 minutes. My name is Benz. I work at Microsoft. I'm a cloud developer advocate. I'm based in Las Vegas, and I just came here I'm going to DevOps next week and a few other things. So actually, I love coming here. This is my, I think, 5th year I've been here, and I really enjoy JFall. So thanks for coming to my session. And so we're going to talk today about reliable code delivery with OpenTracing. I'm going to show you a demo that I actually just put together with some guys from Red Hat as well last night, yesterday. So we got an OpenShift running as well with some demos and things. But first I'm going to talk about a little bit about microservices, microprofile, and then OpenTracing. Then I'm going to show you some demos running locally and how you can set up OpenTracing. We're going to use Jaeger, which is a visualization, open source visualization tool for OpenTracing, with Thorntail, which is Red Hat's microprofile reference implementation. So that's basically what we're going to do. Let's start with Eclipse microprofile. So how many people here have worked with microprofile at all? Okay, just a couple? Cool. All right, well, you're going to learn how you can actually use it. It's pretty easy to use. So the idea here is you've got a bunch of microservices. How do you actually design a microservice so it can communicate easily with other microservices? You know, we're all in this container-based world. About 100 years ago, I wrote a book called the XML Programming Bible, and in there I covered web services. For those of you who might remember things like that, WSDL and SOAP and stuff like that, everything is new again. So the idea here behind microprofile is very similar to what web services were trying to accomplish as well, which is basically having an interoperable way that microservices can work together with each other. So let's say Oracle or IBM or Microsoft wants to build an API to a tool. Wouldn't it be great if you could actually build a microservice for a SQL Server or for DB2 or for Oracle, and then you could just provide that microservice to a central sort of location that could automatically use that with a little bit of addition. That's the idea behind microprofile. There's actually much more to it than that, but that's basically the idea. So it's a community of organizations, vendors, who want to communicate and make microservices easily interoperable. And the motivation with microprofile is to avoid fragmentation, build quickly through lazy consensus. So basically just put out some standards there, the bare minimum that you would need to connect microservices together. And if you write an interface in that way, then it should interact with other microservices. Yeah, I threw that caveat in there. Because there are a lot of challenges to this, obviously. There's a lot of different things that need to happen to make a database connect and a OpenTracing or some kind of log tracing server connect as well. But the whole idea right now is you sort of tie all these things together through Maven, through POM, and allow them to discover themselves that way. And I'll show you some examples of that later. Here's a little bit of the participants in the microprofile community and some of the microprofile implementations that are actually done out there. And let me just show you a website here. So microprofile itself, there's a website out there, microprofile.io. And then inside there are contributors. I'm just going to skip ahead a little bit here. OpenTracing also has a bunch of contributors that you have through a registry. And microprofile contains OpenTracing now as of, I believe, 1.2 of the versions of microprofile. So a lot of different vendors are building things that will work with OpenTracing and therefore work with microprofile. And some of those things, C#, Go, Akka, Java agents, there's a bunch of them here. It changes all the time, so I like to look at the live version of this. Scala, several different things for Ruby. There's several interfaces you can use for this, and I'm going to show you a microprofile connection using Jaeger, which is one of the tools that you can use for OpenTracing as well. So microprofile implementations, these are some of the vendors that have put their weight behind these. So major vendors with major products that are looking to interop with each other. Today I'm going to show Red Hat's microprofile reference implementation, which is Thorntail. And basically Thorntail allows you to use Maven as the glue to hold together microprofile microservices that are running by themselves. It's optimized for containers. You can build an uberjar or a war. In this case, we're going to build wars. And it implements microprofile 1.2, which is good because that's what we need for OpenTracing. So to use Thorntail via Maven, you basically just have dependencies. You add a Thorntail dependency, you add a bill of materials, and you import application code, and then you add other dependencies in, and I'll show you some examples of that later. Some of the other things you can do with Thorntail, there's a way to do configuration injection to allow you to add different tools and functionality. And there's things like health probes. So you can automatically add a health probe into your application. It's already built into Thorntail. All you need to do is add some annotations, and those annotations will automatically run health checks on your application. And that enables things like some of the finer points of microservices, circuit breakers, and back pressure and things like that are automatically implemented with, if you're using Thorntail or any microservice implementation. Metrics. So metrics, you can add metrics automatically. I'm going to show you Jaeger, as I mentioned today, and fault tolerance. So you can do things like I mentioned, circuit breakers, back pressure, and things like that to implement. And obviously, when you're running something like this, there's several different layers. So Thorntail's the microservices reference implementation, so that's the actual code level for a single microservice. And then you have scaling. How do you handle scaling in a microservice? And for that, there are several platforms. Cloud Foundry, OpenShift was Red Hat's implementation. Microsoft has a implementation of a microservice platform called Service Fabric as well, and Service Fabric Mesh, which is coming out too. So there's several platforms that you can use to run Thorntail or any microservice microprofile implementation, and that implementation should actually adopt a lot of the advantages that you would have for microservices in general. So that's the idea. So adding Jaeger to a Thorntail app. So Jaeger is actually it's part of microprofile, but it's also independent. It's part of OpenTracing. OpenTracing is a separate implementation which is run on top of microprofile. It's now part of the microprofile project. And Jaeger is a visualization tool that you can use for that. So let me show you Jaeger real quick. So Jaeger itself implements three things with OpenTracing. They have a Jaeger agent, which basically runs Jaeger, and then you have a Jaeger collector, which actually grabs traces that are sent to it via UDP. And then you have a Jaeger query, which runs queries on the data that actually gets collected. So there's three basic components there, and there's a Docker file you can use called Jaeger Tracing All-in-One that actually has all three of those components pre-built. I'm going to show that in action in a couple of minutes. So that's an OpenTracing implementation, and all you need to do to add it to your Thorntail app is add a dependency in your POM. So all you have to do is plug this in, say IO Thorntail, and then add Jaeger. There's also an OpenTracing dependency you can add as well, and I added that in OpenShift to show it to you a little bit later. But that's the advantage of working with microprofile and work with OpenTracing. It's, somebody says, okay, we want to add tracing to our application. Okay, just add this dependency, rebuild the actual Thorntail app, and this will be pulled in. Everything you need to run everything you need to run Jaeger and OpenTracing will be pulled in via this dependency. So let's look at a couple demos. It'll become a little more clear, hopefully, once I get some of these going. So what I've got here, I'm going to show you let me see here. What do we got? Okay, we got that, good. I'm actually going to show you an application running. All we have is we added to the POM XML, as I mentioned, we added Jaeger. I'm going to fire up, what happened there? I'm actually going to fire up Thorntail running an application. Whoops. What happened here? Oh, wrong application, Bri. Hold on. That's not the one we want. We want this one. Okay, there. Better be in the Thorntail app before we run Thorntail. So basically you just say Maven clean Thorntail run, and this actually runs an application. Let's pull this up. So it's actually building the application right now, and it builds a WAR file. Behind the scenes, Thorntail runs app server. Anyone want to guess what the app server is? It's Swarm. Wildfly. It's a Red Hat Wildfly implementation behind the scenes. That's why we need a WAR file, because it's a Jakarta EE. Anyway, it's running up, and you'll see here, it's kind of hard to see, but you'll see some fractions. These are based on the POM XML. And Jaeger stable was added, logging was added, something called undertow, a bunch of different dependencies were pulled in automatically when this starts running. So it says Thorntail is ready. All right, so let's fire this up. And let's go to, some of you might recognize this app. Uh-oh. Oh, great. Hang on. Thorntail is ready. Come on. There we go. I don't know why it took so long. Anyone recognize this? I was reading an article the other day. This is Minesweeper. This is a microservices implementation of Minesweeper. Behind the scenes basically has an H2 database, and when I can click around here and play Minesweeper, and the player name automatically gets added there. So automatically adds a score, and I keep playing this, and it just basically runs. It's got some JavaScript on the front end. It's got a microservice on the back end. It runs Thorntail on a Jakarta EE server, and that is implementing a read and write to a database. In this case, I'm using an H2 database. It also has a default connection to a Cosmos DB database, which is MongoDB compatible backend NoSQL database that we've built at Microsoft. It's actually called a multi-model database, but that's not what I'm here to talk about today. Okay, so we got this running. So what? It's running okay. Now let's add Jaeger. Now, if you remember, I added Jaeger with a dependency, so I showed you that little dependency there. Now, all I need to do to fire up Jaeger, I downloaded the all-in-one application already. So let's just fire up I'm just going to run a local Docker, and it's going to run. All right, I think that's it. It doesn't take long to fire that up. Oh no, it's still running, sorry. Okay, anyway, we'll get in here. And we'll see what's going on there. There, okay. So we're running Jaeger locally. This is Jaeger OpenTracing implementation. And because I added that dependency into that little Microsweeper app, right now, as you can see, there's nothing here because I just started it up. But if I go back to my app now, every time I play Microsweeper, here it is, it's actually going to write data to my OpenTracing implementation, which is Jaeger. Come on. I read an article yesterday that Bill Gates was addicted to this game. I don't know why. It's really kind of an annoying game. Wow. This has got to be great, except I was trying to do a demo, guys. There we go. Okay. So I usually try to do it a couple times. Okay, there we go. One more time. So there should be 3 traces, basically, in here. And I'm going to explain what tracing is later. Don't worry. For those of you who might not be familiar. So if I go to my Jaeger implementation now, and I refresh it, now I want to drop down. You see it's got a Jaeger query. So Jaeger query is basically just tracking implementations. I did this yesterday, so that's what those are. But the ones I just did a few seconds ago are right here. And you can click here and you can see how long this particular span took. I'll explain what a span and a trace is in a second. It took 0.5 milliseconds to write to the H2 database. And when I click the restart, it takes a little while to start up. Basically, when you look at Jaeger, without giving away too much about OpenTracing yet, down here, this is good. The lower that this little ball is, the better the performance is. And the higher up, like this one, wasn't very performant. And also, if this ball is larger, that means the actual process inside that span took a little longer than it should have. So anyway, so that's the, oh, actually, before I go any further, so I wanted to show you one more thing here. So that's just Microsweeper running. So without killing my, this is still running, good. So I will go in here. So this is actually the application, yes. So I'm going to stop that now. I want to stop that application. Then the next thing I want to do is I want to fire up, I wanted to show you a little bit about how that actually works. So I use the basic dependency for that, as I mentioned before, and I fired up Microsweeper. Thorntail also has several properties that you can use to pass more information. So that's a basic Jaeger query there. But you can also add things like, let's go to the docs. You can add different properties to Jaeger as well in Thorntail, like an agent host. So if there's a remote host, because it's on the local machine, it picks it up via UDP. But you could also communicate with a remote host running on a container somewhere out on the web that collects multiple items from different applications. And there's several other things you can do, the flushing intervals for the database, things like that. So there's lots of configuration you can add. You can also add in Thorntail more annotations in your application. And OpenTracing and Jaeger will pick up annotations when it's tracing things as well. All right, so let me show you this. So that's still running, good. So the next thing I want to do is I actually want to show you a different way to implement this without Thorntail. You can actually build I've got a Spring Music application, which is Spring. And they don't have a cool name for their microservices implementations, but they actually have something similar. It runs on Cloud Foundry as a platform versus Red Hat's OpenShift and Thorntail implementation. But in this case, what I did is I actually wrote some code in an application called Spring Music. How many people are familiar with Spring Music out there? It's a demo app. It's been around since 2015 or something. Okay. Anyway, all I had to do to add OpenTracing to my Spring implementation was build a sidecar. And I built that sidecar with this code, which is basically Cloud Foundry implementation. It uses a class from Lightstep, which is a vendor, provides OpenTracing as well. They have their own UI that sort of competes with Jaeger, but Jaeger's a free open source tool. So basically to build this, you build a tracer, load Jaeger tracer, and you name your service Spring Music. So instead of having just Jaeger query, you'll have something called Spring Music that can actually trace things on. So let's actually run this. All right. Where is that? Hold on. Yeah, this is in here. Okay, so let me just open this. Let's see, GitHub. Oh, wait, actually I can go this way. Spring Music Azure. All right. Yeah, this is the one. All right. Make sure I got the code. I don't want to try typing this. This is the one I tried to run earlier. So this is a Spring app. It's running, and it's got that sidecar added as well. And it runs and it starts. Let's make sure it's running. So it's actually running spans right now. So as you can see, there's a lot of different things that go on. So this one's a little more complicated with the OpenTracing. Oh no, it failed to start. Oh, I know why. Remember I did that Control-Delete for those of you who showed up a little earlier. Sometimes, yeah, sometimes there is, yeah, that little guy has to be killed. There you go. Because I'm running Docker connecting to that application, sometimes the Java doesn't shut down quite as well as it should, so I have to go in and kill a little process there. And now, it'll run. It better run. There it goes, it's doing more logging. So basically this is a processing a bunch of logging that's going to go to OpenTracing. I'm going to show you what we're actually looking at back there in a minute. Okay, so the application is running. So now, if I go into my browser and I go to Minesweeper, it has been magically changed to Spring Music. So Spring Music is just a little application that you can run. There we go. And it basically just shows you the last 500 albums, of the top 500 albums of the last 50 years, I believe. I got the data from Kaggle. I added it to it. But if you go to my GitHub Benz Spring Music Azure, you'll see it, or just search Spring Music Azure. It'll bring you there. So that's the application. And now what we're going to do is we can do something kind of cool. I'm actually going to load this with 1,000. I'm going to load this with 1,000 hits. Does anybody know what a hey is? It's a. This is a very cool thing that you guys might like for testing. Where is it now? Hey. Is it there? Nope. There it is. So this is a. It's on. It's a application that's written in Go, and it actually allows you to hit a URL with a number of hits and a number of concurrent users. So it pretends to be a bunch of users to test something really quick. I mean, we have JMeter and things like that to do some testing as well, but this is actually a nice and easy and quick because I can do things like just open a command prompt, and if I say, I've already converted it to a binary, it's a Go app, but you can write an exe, and then localhost 8080, it's going to hit that website 1,000 times, and it's going to look like 100 concurrent users. So I hit it, boom, hit it. There you go. So it gives me a bunch of data. I will go to that. If you look on the website, it shows you what the data is, but basically it's a bunch of response times and things. It's actually pretty cool for really just quickly testing something. And in this case, the reason why I'm using it is we can go back into Jaeger here, use the same Jaeger server because it's picking things up via UDP. Spring Music is now on there. And Spring Music, when I do the last, let's do the last 200 hits. You can see here a bunch of different traces over here. And as you can see, performance started to degrade as things went on. So things are a little bit higher. And you can set different parameters for thresholds and things to test this and tell you when things are getting overloaded and stuff like that. And basically, the idea here is it could track a bunch of different spans. So that gives you an idea of some of the data you can use for that. And that's running locally. So now let's actually talk about what we're looking at here in Jaeger. So that's a couple of different examples of connecting OpenTracing. You can use Thorntail implementation, just add a dependency, or you can use a sidecar using some Java code, and that's all out on GitHub. So talking about OpenTracing now, what did we just look at? I showed you how to integrate it. Now let's talk about what it does. So today's tooling landscape, there's a lot of complexity. We're moving from monoliths to containerized applications. I heard a great quote a while ago. It's, you know, microservices are a way of dealing with the problems with monoliths. Containers are a way of dealing with the problems with microservices, and then Kubernetes and other orchestration tools are a way of dealing with the problems with containers. But basically the point is you've got a lot of complexity now and a lot of pieces working together. And how do you actually track your application performance from end to end and make that and make sense of what's happening? So the idea with microservices and with OpenTracing is that you've got, let's just get down to that one. You've got different concurrency that needs to happen between different containers, and you've got some loose coupling that's happening between microservices. How do you actually track performance between there? If you have some problem with your profile update performance, how do you know what is actually the cause of that performance issue? And the way you would do that is by using something like OpenTracing. In this case, distributed tracing. You can actually track something from one end of the application to the other. I'm going to flip through this really quick. So getting to the meat of the matter, what is a trace and what is a span? So a trace is something that traces a process from end to end. So profile update. You go in, you hit edit, you do something in a profile, you hit save. What happens during that process, and is it performing as well as it possibly could? What you do is if there's a handoff between microservices, each microservice would track something called a span. And then spans are aggregated into a trace for that end-to-end process. So that's what we're looking at here. You've got a parent span, you've got a child span. Each one of those is logged. In this case, it uses UDP to actually just throw something out into a Jaeger collector, and that Jaeger collector will actually aggregate the data from spans into traces for you. And a trace is a collection of spans. So how does this actually work? Well, you can track things like errors. What exactly is the cause of an issue that happens only once in a while? You can track things like your performance when you're actually deploying things through CI/CD. So, for example, if you're using a Kubernetes cluster or OpenShift or Cloud Foundry, when you do an update to an application, it updates one pod at a time. How do you know that those pods are efficiently running before you actually put that into production? You can use OpenTracing to actually trace through those pods as they're being updated to check and see if performance is okay and if you want to roll things back to the previous version, things like that. So it gives you a lot of flexibility, and there's a lot of built-in tools, as I showed you before. with the registry, the OpenTracing registry, there's new ones all the time. So Hazelcast has its own Jaeger OpenTracing interface for you. Java interceptors, all kinds of things you can use out of the box to trace certain kinds of microservices or certain kinds of non-microservice services that are providing OpenTracing integration. So the example here, an old application would have a client, a web server, and then you've got auth, billing, and a database for, I don't know, hotel bill, something like that. In this case, in a modern app, you've got a client, you've got a web server, and then these are separate independent processes. And that's how you actually track the traces. So each one of these would be a span, and then you've got a trace that runs the entire length of that process. So the OpenTracing API, as I showed you before, it's a marketplace where you can actually, well, there's more than just a marketplace. There's a API that you can use, and the idea is that if you're using something like MicroProfile, you can automatically use a dependency to plug in OpenTracing API automatically, even if it's not just OpenTracing in general, but something like Jaeger to pull that in as well. And or you can write an application, like I showed you with Lightstep, the sidecar that actually pulls in, actually enables OpenTracing data as well. And as you can see, there's not a lot of code here to actually implement the tracing for that Spring Music app. It's just a few lines. Add the classes that are already there because they're standardized API. From Lightstep, it actually writes the correct tokens based on annotations for Spring Music. Okay, so as I mentioned before, application logic. You got your OpenTracing API. I'm showing Jaeger today, but there's other ones as well. There's some of them are paid services, some are free, and you can build the tracing infrastructure basically the way you want. There's also New Relic and other traditional logging tools who are building OpenTracing interfaces as well. So companies that use OpenTracing, here's some of them. It's very useful for web companies who are doing a lot of quick iteration for their applications, especially if they're container and or Kubernetes based. Hundreds of projects out there, lots of tracers, and a bunch of different languages you can use with OpenTracing as well. So running a server. So how do you actually implement something on a server as well? So I showed you the Docker Hub image for Jaeger tracing. For those of you, who works with Kubernetes here? Right? A few people, okay. You guys are gonna like this. This is something, who knows about the kubeapps site? Okay, just a couple of people. See, this is good. Just reminded me of this. So kubeapps is it's like Docker, but it's for Kubernetes. Anyone who's tried to write a Kubernetes manifest from scratch knows how painful it can be. So Helm is actually a tool you can use to quickly build and deploy Kubernetes and Kubernetes charts, or they're called charts, Helm charts. So Kubernetes charts are built using Helm and Draft, which is actually a company that Microsoft built, Deus. We bought it a while ago. This is a site built by Bitnami. So Bitnami has basically aggregated a bunch of tools that you can use for deploying different applications, open source applications, out to Kubernetes. So if I look at Jaeger, so there's a couple here, Jaeger Operator. So you can take this and run it on Kubernetes right away on any cloud platform you want or your own on-prem platform. It's kind of cool stuff for building that. So kubeapps is a handy tool for that. The example I want to show you today, though, I implemented OpenShift. Where is it now? So I've got the same Minesweeper here that you saw before. I've got Jaeger running on OpenShift. So this is OpenShift Origin, which is the free version of Red Hat's OpenShift platform. So Thorntail is the reference implementation for MicroProfile, and OpenShift is a enhanced version of Kubernetes. So it's Red Hat's Kubernetes implementation. They don't use kubectl, they use OC, which is slightly different. But they've added a whole bunch of stuff here, like I can do pipelines and builds. And in this case, what I've got is I've got a Microsweeper build, and I added some environment variables to it. And those environment variables allow me to track, hold on. The environment variables, okay, not there. I just set this up last night. The actual, application deployments, that's what I needed. Microsweeper, environment variables, good. Okay, sorry, still finding my way around this. This is Red Hat's implementation of Kubernetes, but what I can do is I can take that Microsweeper app, and I showed you before some of the Thorntail properties that you can add. So these are the properties that I've implemented here, and some of the settings that I've got, and I call this one Jaeger agent, but there's also a service name called Microsweeper. So that previous version I showed you on my local machine was called Spring Music. This one's called Microsweeper, and I've actually got this working with Cosmos DB using a secret that we use with Microsoft Key Vault, Microsoft Azure Key Vault, to actually process and allow that to access the database of the backend secretly. It uses a MongoDB API. So same thing. Oh, there we go, yay. If I just play around with this a few times, I've got, there we go, come on, there we go. So this is Minesweeper, but it's actually working down here. It's writing to Cosmos DB, and it's actually using those environment variables that I showed you in OpenShift. When I do that, I've got the Jaeger version of this. That's the one. Let me refresh this. So this is running on OpenShift, which is running on Microsoft Azure. It's the OpenShift Origin version, which doesn't need a license, and you can play around with it. So this is Thorntail running, so it's MicroProfile running the Thorntail implementation running in OpenShift, which gives you a bunch of different microservice cloud native functionality that is handy. And what I can do here, now that I've got, as I mentioned before, we added an environment variable called Microsweeper. We've got that here, and if I find traces, it shows the traces that I just did. And basically this time it's pretty boring. There's just one span. This is actually a span in this particular trace, and it writes to the Cosmos DB database, and it's taking 2.86 milliseconds to write, so that's pretty good performance. For some reason, this one wasn't too good. It took 473 milliseconds, which still is not bad, it's half a second. But as you can see here, the implementation itself uses some environment variables and other things to add. You can also do class level annotations. You can pull in, you could add a sidecar to this. You could do all kinds of things to actually implement OpenTracing as well. And I mentioned this is on OpenShift Origin. So what we did is we actually used these are different back-end data sources you can use using object brokers that we've implemented in a multi-vendor project that's been built. And that is something, so we've got all kinds of databases on the back end you can use for this. And also things like Jenkins. We actually have as well set up a build pipeline in here that actually runs this and pulls this. It pulls from GitHub, and it actually runs the tests, it adds those environment variables to it, and then deploys out to production into a Kubernetes cluster, which is the OpenShift version of Kubernetes. And that is all I have. I believe we have 5 minutes left for questions. I've got, I was going to show you a little bit about the CLI. I talked a little bit about the Kubernetes and some of the platforms that we have for actually running this. So Docker, Kubernetes, OpenShift, and Cloud Foundry is a great way of running microservices, including MicroProfile. And we actually have our own service fabric as well for that. And I showed the OpenShift. That's a couple pictures that I was going to show if things didn't work, and they did work, so there we go. And there's some reference, and I'll take questions. Is there any questions on, yes?
You gather a lot of data.
Yes.
With the tracing, which really cool. You can trace over tooling and over microservices.
Yes.
What is the main takeaway that you get from that data, which you can actually use to, well, for instance, improve the quality of your stack or something else? What do you do with this data you gather actually?
Right. Okay. So, so the question is, what can you actually do with this data when it's actually working? So this is my local version of this running. Basically, this is a very simple example. So you see there's not a lot of data here. But a more complex example would have, and by the way, Jaeger is a free product, so it's very basic in its graphs and things. And when I click on any one of these traces, you can see the traces here. But generally what you can do with a lot of tools, including this one, is you can set thresholds and things and color coding and stuff like that. And you can actually have automatic reporting. So you can have, for example, something like Jenkins that runs a test and runs through the total process. Use something like JMeter to actually load test the application itself, and then tell you where you're going to have latency issues and problems like that. Like I say, these are just single spans, but normally in a really complex application, you would see a bunch of different spans here handing things off to tracing. Let's see if I can find one. Sometimes there's an error in here. Now, see, anytime there's an error spawn, for example, I'll have an error span that pops down here. So then you can report back automatically. If there's any error spans, you would text someone or ping and say, hey, there's an error span that's happening in this application, and this microservice is causing that. And it's causing this impact on your tracing. Now, it gets a little more complicated when you're running into things like the platforms I mentioned, OpenShift and Cloud Foundry and stuff like that, because you can have circuit breakers and back pressure and things like that. So if there's a lot of back pressure on a certain node that's running all the time, you want to report that immediately, and that would be tracked in the trace. So you'd have a trace that actually tells you which containers were failing or which containers were overloaded, and what happened when we, because normally what will happen in one of those cloud native platforms is if something does get overloaded, it'll shut down that container and open up another one, assuming there's something wrong with it, or it'll start distributing to other containers in other pods in the Kubernetes cluster, things like that. And you want to know what happened during that process where you switched over to the other one. So just before that process, what happened to that container? There might be several microservices running inside that container, and it'll tell you in the spans which one was slowing things down and which caused the circuit breaker to trigger, or what caused the back pressure to trigger as well. So that's the kind of thing. This is a really simple example. It's like it's a hello world kind of example. It's a little more complicated than that, but yeah, normally you'd have a bunch of different spans going down the whole page. So, any other questions? Yes.
So, if I understand correctly, this is a sort of can be used as a post-mortem analysis of what went wrong.
Well, it's live. So you're,
also live.
yeah. So he's asking.
You can also use it to find, let's say, bottlenecks in your process.
Yes. So the idea, yeah. So the question was, can you find bottlenecks in the process? And this is, can you do postmortems after? Yes, you can do both. So, but the whole idea is this is live, and the application is still running, but you're discovering latency with a sort of fairly lightweight, because it's loading everything via UDP to the collector, you're able to sort of trace through that application separately from the application itself. You don't actually need to see what's happening, but yeah, it does take sort of a snapshot. So each one of these spans would be a snapshot of a process at a certain period of time, and the trace actually runs things through end to end. So.
But this does not allow you to annotate or analyze the data afterwards. You have to do a separate step for that.
Oh, the question, yeah, it does actually allow you to do that after. I've got data in here. I've never flushed the cache on this thing, so I've got data in here from a long time, actually. If I can do a search, 1,500, okay. One of the limits of Jaeger, it's a free tool, so other tools will have more, but I've got a lot of, I've got a lot of data here. I've got a lot of data here. I've got a lot of data here. It's taken a while to return the query, I hope, or it's crashed, one or the other. It's running on my local machine. But yeah, there we go. Yeah, took a while. So here's some spans. This is today. This is yesterday. As I mentioned before, the larger circles mean slower performance in a span, and higher up means slower performance in a trace. So let's click through to this one. Click through this one. Anyway, it's slow because it's on my local machine with a poor overrun H2 database. I've probably got literally hundreds of thousands. Yeah. I've got like hundreds of thousands of traces in there. So there we go. And so yeah, you can do it over time, and you can track as much as your database will hold. The default is an H2 database, but you can use other back-end databases for Jaeger as well, or other tools. So.
My question was more or less, suppose you want to see, does my problem always occur at 5 o'clock in the afternoon?
Mm-hmm,
and you aggregate with that kind of views. Say, okay, I want all the data from 5 to 6 for every day.
Yeah. You can.
Only on Mondays, or.
Yes. The answer is yes. So you can do things like you can time box this. So you can say, I want the results from a certain period of time. So maybe Monday mornings are busier than other times or slower than other times. You want to know why. You can also do things like minimum duration, maximum duration for the trace. Yeah, I was doing a very simple one, but you can do all kinds of things. So these are all the different, this is for Spring Music. These are all the different processes that run that I can actually trace things on. And then you can time box them. I can't remember how to do that here.
I'm talking about more like analysis.
Right. So this is Jaeger's a really basic tool, but OpenTracing can be used with things like New Relic or other tools. Lightstep also has tools. Instana. To actually, I got 2 minutes, but so it'll actually, the tool itself, don't confuse the tool itself with OpenTracing. So this is Jaeger. It's an open source implementation. I think Jaeger even has I can't remember if they have a paid version, but other more robust paid versions allow you to do things like you're talking, time boxing and stuff like that. New Relic, of course, Instana. These are tools that allow you to do, you take the traces, which is the data, and then visualize it. So Jaeger's a visualization tool. It collects the data, but it also does queries, but it's really basic, and it is open source. So you could time box it as well using Jaeger, but you'd have to write your own code. Okay. Yeah.
So is OpenTracing about the instrumentation then?
Yes, OpenTracing is about the instrumentation. OpenTracing is actually, actually let me take that back. OpenTracing is about tracing the data, collecting, tracking the data. And then you have different collectors, like Jaeger's a collector. And then you can have other tools to actually analyze what was collected. So you've got 3 things. You've got your agent, which actually runs the OpenTracing. You've got the collector, which actually collects the data and puts it in a repository somewhere. It could be anything, in this case H2. And then you've got the query, which allows you to analyze the data. In this case, the query is really, really simple. So, all right. Okay. Any other questions real quick? think we're out of time, so.
I was wondering if
Yes.
how can you put this in perspective? If you compare it to Prometheus, or which also does counts, metrics collection, gathering, query.
Yeah, so the question was comparing this to Prometheus. So Prometheus, so the idea with OpenTracing though is they've got sort of more of a vendor buy-in. So as you can see here, all these different providers and all these different languages are built for OpenTracing. And Prometheus is perfectly fine as well. This is just one of the solutions. It's included with Microprofile, which is why I highlighted it today, because you can use Microprofile, you can just add that little dependency, and all of a sudden you've got OpenTracing or you've got Jaeger, because they've all agreed to work with the OpenTracing standards. So that's basically the idea.
Yeah, I'm wondering
Yeah.
if that's a good combination or replacement altogether.
Is it a good combination or a replacement? I think they complement each other, really. In this case, you know, OpenTracing, because they have so many vendors, you got buy-in, you could quickly plug something in. If you want to build something like this in Prometheus, from what I understand, you'd have to sort of write it from scratch. Yeah. Yeah, in this case, a lot of it's written for you. So I can just plug in that dependency, fire up Jaeger and see what happens. And if I need more info, I can buy another third-party tool like Lightstep or one of the other tools that allow you to do more with your data. Yeah, thanks. All right, guys, well, thanks for coming. I'll be around if you have any more questions. And I think we're out of time, so thank you.